Uh, Students, can you hear me? Can you hear me, students? Right, good. Right, okay. So, good evening for all of you. So, today we are going to start our pre-A level foundation program. So, I have uploaded the PDF to WhatsApp group. Okay. So, therefore, you can refer the PDF. So, let's start. Right. So, you will get the tutorial, hard copy of the tutorial by next week. Those who send me the addresses, right? So therefore, let's start. So what we have to discuss today, okay? So while we are discussing these things, if there are any important things, I will notify you. And if you have any doubts, please use the chat box in order to raise your doubts. Okay, right. So right. So today is the first session that we are going to conduct related to this foundation program. So in the page number 1, I have given you. This is actually our local syllabus. Complete question pack is MCQs and structured. Prepared for students entering the advanced level, chemistry through bioscience stream and physical science stream. And so you can fill your name, your school, and everything in that first page. So let me directly go to the introduction. So they have given this tutorial booklet has been designed for students following the pre-A level chemistry program under the Sri Lankan local syllabus. It covers the essential fundamental concepts required for a smooth transition from ordinary level science to advanced level chemistry. Okay, so what is the target of conducting, what is the purpose, intention of conducting this pre-A level foundation program is we need a smooth transition from your O level science to A level chemistry. So that's why we are conducting this one, right? So there are some questions that we have to discuss in this book, right? So there are 8 topics, right? And there are MCQs and structured essay questions from each topic. The questions in this booklet aim to strengthen basic conceptual understanding, build confidence in answering chemistry questions, and introduce A-level style thinking through structured essay questions. Provide adequate practice in all core areas needed before entering A-level. Okay. Each topic contains 10 multiple MCQs, multiple choice questions, and 5 structured questions. And look at the topics that we are going to cover. So covered topics will be, so number 1 is actually atomic structure. Second topic is periodic table. And third topic is chemical bonding. Fourth one is mole concept and stoichiometry. Mole concept and stoichiometry. And fifth one is state of matter. Number 6 is basic organic chemistry. basic organic chemistry. And the seventh one is, topic number 7 is actually acids and bases. Number 8 is redox. Redox. Redox means actually reduction and oxidation. So these are the topics that I hope to discuss with you. Okay. Atomic structure, periodic table, chemical bonding, mole concept and stoichiometry, state of matter, basic organic chemistry, acids and bases and redox. Okay. So today I hope to discuss these two topics, atomic structure and periodic table. Remember students, now don't think that this is not our A-level syllabus. Okay. Our A-level syllabus is containing 14 units and the content is very big. Okay. So as I told you, here we are going to discuss about the foundation. That means I'm going to teach you some important points that you have to know about this topic, each and every topic. I'm going to take each and every topic separately, and we are going to discuss some questions and what you should know about this topic, right? Under this topic, what you should know before you go for A levels, right? So that is kind of a foundation, right? So today I'm planning to discuss about these two topics. I'm going to revise your O-level chemistry theory knowledge and let's see how it is combining to the A-level theory. Okay, A-level chemistry theories. So this is what we are going to discuss first of all today. Today I'm going to cover atomic structure and periodic table. Okay, right. So do you have the PDF with you? I have sent you the PDF to the WhatsApp group. So please refer the PDF, okay? Right. Now let's move to the first topic. So what is the first topic? So the first topic is atomic structure. Topic number 1, atomic structure. Okay. Right. So first of all, they have given 10 MCQs. So let's move to the MCQs. Number 1, number 2, number 3, 4, 5, 6, 7, 8, 9, 10. So likewise, they have given 10 MCQs. Okay. So let's go one by one. So the first one, which subatomic particle carries a positive charge? Students, they are asking which subatomic particles carries a positive charge. They have given 4 answers: electron, proton, neutron, positron. So what do you know about these things? So first of all, tell me what is the answer for this one. After that, let's go for the discussion. Yes, Rahana, you are correct. What is the basic fundamental positive charge? It is a proton, right? Remember students, when we consider about the subatomic particles, right? In A levels also we are discussing about subatomic particles. There are 3 subatomic particles that we have to discuss. One is electron. Okay. One is electron and the other one is proton. And the next one is neutron. So these are the 3 subatomic particles that we have to discuss. Okay, you have already learned about these things in your O levels also. These are the 3 subatomic particles. Now in A levels, remember students, our first unit also atomic structure. In the first unit, we are discussing about the subatomic particles in detail. Who discovered the electron? What is the mass of electron? What is the charge of electron? Who discovered the proton? Who discovered the neutron? What is the charge of it? Likewise, right? So if you summarize about these 3 subatomic particles, look at this one. First of all, If I consider these three subatomic particles like electron, proton, and neutron, okay, these are the things that you have to know. Don't worry, again, we are learning these things under unit number 1. Okay. First of all, you should know who discovered these subatomic particles. Discovered by. And the next one is, what is the mass of this particle? What is the mass? Then you should know for the mass, let me extend the column in this way. Then you should know what is the charge of this particle. Then you should know what is the symbol, right? There is a symbol for this particle, each and every particle. Then students, you should know what is the relative mass and what is the relative charge. Relative. Okay, let me put the symbol at the end. Relative mass, relative charge, relative mass, relative charge, and what is the symbol of the these three subatomic particles. Okay. Now we are going to discuss these things in A level also, right? You have to know about these things, right? What are the three subatomic particles that we are discussing? Electron, proton, neutron. Remember students, when you discuss about these three subatomic particles, the first thing that you have to know is, what is the first thing that you should know? Remember, electron is the basic negative particle in the matter, right? If I consider atom, yeah. The basic negative particle in atom is electron. Then what is proton then? Right? This question is related to proton. They are asking which subatomic particle carries a positive charge. So remember, what is the basic positive particle? Basic positive particle is proton. Right? Basic positive particle is proton. Right? Actually, we are learning about, in this lesson, we are going to learn about something known as cathode rays. Right? In the first unit, we are discussing about cathode rays. Cathode ray experiment. Right? Using the cathode ray experiment only, they discovered the electron. Electron was discovered by J.J. Thomson. There is a scientist known as, so you have heard that one, you have heard about him all over time also. Electron was discovered by J.J. Thomson. Right? So for the proton, we can say that proton is actually, we can consider it is hydrogen nucleus. Actually, it is H plus. Students, proton means none other than H pluses. Right? Then what does mean by a neutron? Remember, neutron is the neutral particle, basic neutral particle inside the atom. Understood? Basic neutral particle inside the atom is what? Right? Electron is the basic negative particle, proton is the basic positive particle, neutron is the basic neutral particle. And electron was discovered by whom? Electron was discovered by J.J. Thomson. Neither J.J. Thomson. Tell me, proton was discovered by whom? Anyone here? Tell me who discovered the proton? Proton discovered by whom? Proton was discovered by? Yes, very good. Ashfa? Ernest Rutherford, right? Ernest Rutherford. Ernest Rutherford. Tell me who discovered the neutron? Neutron was discovered by? Electron was found by J.J. Thomson. Proton was found by Ernest Rutherford. And neutron? Yes, very good. Neutron was found by James Chadwick. What is the name? James Chadwick. You have to remember the names. Okay. Remember, students, we have a separate story for the electron. We have a separate story for the proton, discovery of proton. We have separate story for the discovery of neutron. We are learning those things in detail under unit number 1, atomic structure. So here I'm going to give you a summary, a foundation that you have to know. So every student should know this kind of a basic summary about these three subatomic particles. Next thing, What is the mass of electron? Right? Remember, students, when you consider the subatomic particles, right, the least mass belong to electron. Electron's mass is 9.107 10 to the power minus 31 kilograms. This is the mass of electron. And what is the mass of proton? Mass of proton is 1.672 10 to the power minus 27 kilograms is the mass of proton. And mass of neutron is 1.675 10 to the power minus 27 kilograms. Understood? Yes, you have to remember these three values. Okay, students, you have to remember the mass of electron, you have to remember the mass of proton, you have to remember the mass of neutron as well. Okay, so these are the masses of electron, proton, neutron. And the next thing, what is the charge, right? So what is the charge of electron, as you think? So the charge of electron is considered as 1.602 10 to the power minus 19 coulomb, right? Proton's charge is also same value, 1.602 10 to the power minus 19 coulomb. So this is actually coulomb. Coulomb, the unit coulomb is used to measure the charge. Right now in physics, you will learn that the first unit is unit and measurements. And there you will learn that about units. Coulomb, unit coulomb is used to measure the amount of charge. Right? Understood? So the only difference between the electron's charge and the proton's charge is this is a negative charge and this is a positive charge. Okay, tell me, what is the charge of neutron, as you think? What is the charge of neutron? Anyone here? Charge of neutron? No. I'm asking about the charge of neutron. Very simple. Charge of neutron is what? Zero. That's a neutral particle. Students, they have name this one as neutron. So therefore, that is the basic neutral particle. Neutral means it doesn't contain any negative charge or positive charge. Understood? So therefore, that is the basic neutral particle. So therefore, its charge is zero. Okay. So now you don't have to remember these values now. I told you now I'm going to teach you these things again on the unit number 1. You just know these kind of values are existing. Okay. And what about the relative mass, right? Relative mass. Now, students, you can see that proton mass is 1.672 10 to the power minus 27. Right? That's a very small value. That means you have to understand that before this decimal point, there are 26 zeros. So then you can imagine how small these subatomic particles are. Understood? So this is the mass of neutron, right? So mass of electron and mass of neutron almost same, 1.672. Neutron is 1.675. So they are almost same. Therefore, we assign the relative mass of proton and neutron as 1, and relative mass of neutron is also 1. Proton mass is also 1. Neutron mass is also 1. And what about the mass of electron? So mass of electron is actually, this is 10 to the power minus 31. That means there are 30 zeros before this decimal. Understood? So therefore, we consider that its mass is negligible. Remember, students, electron's mass is negligible compared to the mass of proton and compared to the mass of neutron. Electron's mass is negligible. So therefore, we are considering that relative mass of the electron is 0. Relative mass of a proton is 1. Relative mass of a neutron is 1. Why we are assigning 1 and 1 to the relative masses of proton and neutron? Because they have the almost same masses. Understood? Almost they have same masses. So what is the relative charge, as you think? Relative charge? I told you before, relative charge is actually Electron is the basic negative particle. Basic negative particle, therefore relative charge is -1. Proton is the basic positive particle, so therefore its charge is +1. Neutron is the basic neutral particle, so therefore its relative charge is 0 in this. Understood? Right? So you can see that here I have given you who discovered electron, proton, neutron. And here I have given you what are the mass values, what are the charge values. And here I have given you relative masses of these three subatomic particles, relative charge of subatomic particles. Now, what is the symbol? What is the symbol that we are using to denote the electron, to denote the proton and neutron, right? It's very interesting. Now, when you are denoting the, right, when you denote the symbol, right, when we denote electron, proton and neutron, here in the left side top corner, right, left side top corner, we mention its relative mass. Okay, we mention its relative mass. In the left side bottom corner, we mention its relative charge. Relative mass and the relative charge. Okay. How we can symbolize them? How we can denote mass of electron, proton, neutron? Look at this one. We use the symbol. I'll tell you what is the letter that we are using for it. And in the left side top corner, we mention relative mass. In the left side down corner, right? So we mention relative charge. So therefore, electrons symbol, right? Electron symbol is E. Electron, E. What is the relative charge of electron? -1. What is the relative mass of electron? 0. Then E -1, 0. Got it? Then what is the symbol of proton? For proton, we are using letter P. What is the relative mass of relative charge of proton? 1, +1. No need to mention plus. What is the relative mass of proton? That is also 1. For the neutron, we can say that relative charge is 0, relative mass is 1 in this way. So these are the symbols for electron, proton, neutron. Right? You didn't learn these kind of things in O levels, right? But in A level students, we are learning these things. Understood? You have to know about this summary. What is the mass? What is the charge? Who discovered these subatomic particles? What is the relative mass? What is the relative charge? And the symbols. Can you understand? Now, can you understand the summary about these three subatomic particles? Raise your hand those who understood that. If you have any doubts, you can ask. Raise your hand those who understood that summary. Okay, what are the doubts you have? If you have any doubts, you can ask me. Right. If you want, you can note down these things in your notebook, okay? Quickly. So therefore, question number 1, which subatomic particle carries a positive charge? So therefore, our answer should be simple B. Answer is simple B, proton. Okay, simple B, proton. And they have given another particle like positron. Remember students, positron is considered as the antiparticle of the electron, right? So don't think that opposite particle of electron is proton. No, it's not like that. Antiparticle, that means opposite particle of electron is positron. Okay, so that's what they have given as positron, right? Right. So therefore, anyhow, for question number 1, answer is B. Which subatomic particle carries a positive charge? That's a proton. Okay. If you want, you can quickly note down this one in your notebook. Right, okay. Yeah, opposite charge of electron is positive, no? So positron should be positive. Yes. Actually, the symbol for the positron is, now this is the symbol for the electron, no? E minus 1, 0. So positron is actually denoted like this. Positron is E plus 1, 0. So that's what considered as a positron. And you can understand that there is a difference between the proton and positron. Okay, proton is p11. Proton has a charge. A proton has a mass, right? But positron doesn't have mass. It's like electron. The only difference is actually the charge, right? Electron is negatively charged and positron is positively charged, right? We are not discussing about the positron, but since they have given that one as an option, I thought of discussing that positron also, right? So this is what you have to discuss. We have to know about the subatomic particles, right? Okay. Shall we move to the second question? Shall we move to the second one? Are we done? Right. Okay. Now let's move to the second question, right? Second question. The nucleus of an atom contains protons only, protons and neutrons, then electrons only, proton and electrons, right? So what do you think? What is the answer for second one? The nucleus of an atom contains proton only, protons and neutrons, electrons only, and protons and electrons. What is the answer for this? Yes, Rohana, your answer is correct. You have learned those things, no? So when you consider atomic nucleus, right? Students, you know that uh, when you consider the atom, right? So this concentrated, positively charged concentrated area, right? This is actually considered as atomic nucleus. Around the atomic nucleus, there are energy levels, right? So electrons are located in these energy levels. This is what we learn, no? In this way, right? So we consider this one as atomic nucleus. So atomic nucleus is containing what? Protons and neutrons, right? So therefore, the mass of an atom is actually concentrated in a small area, confined in a small area. Electrons mass is negligible, as I told you, electrons mass is negligible. So therefore, atomic nucleus is very heavy, right? Look at the mass values. Look at the mass values of proton and neutron. So therefore, atomic nucleus is heavier than the remaining area. Remember, once Ernest Rutherford assumed that atoms look like uh, that means there is a small area inside the atom. No? That is what we consider as the nucleus. So we are assuming that atoms look like a football ground, right? Just imagine this is the football ground. At the middle of the football ground, there is a small bean, right? Very small bean, very tiny particle. That's what we consider as the atomic nucleus. But you can see that other remaining space is actually that empty space, right? That empty space is containing these electrons. But electrons are actually what? Electrons' mass is negligible. So therefore, the mass of an atom is actually concentrated at the middle. Okay, we will discuss these things in detail on that unit number 1. Anyhow, the nucleus of an atom contains protons and neutrons. So therefore, question number 2, answer is B. Question number 2, answer is B. Okay, that's very easy. Right. Now look at the next one. That's a good question, right? You have already learned about these things. Atomic number. The atomic number represents, right? So atomic number is representing what? The atomic number is representing, yes, we can consider atomic number is representing number of protons. Now, for an example, just consider like this, right? So sodium, right? Sodium atom, here 11, and here we can consider this is 23. 11 and 23. Okay. So this 11 is representing atomic number, right? And this 23 is representing mass number, atomic number and the mass number. Okay. Remember, students, atomic number is representing number of protons, right? That's what you have learned in your O-level time. Atomic number is representing number of protons. And the mass number is representing what? Number of protons plus number of neutrons, both, right? Number of protons and number of neutrons, both. Can you understand? Right? So we can say that simply atomic number means what? Number of protons. Atomic number means number of protons. So can we say that atomic number is equal to number of electrons? What do you say? Is it correct? If I say that atomic number is equal to number of electrons, is it correct? Right? If I consider atomic number is equal to number of electrons, not at all the time. Okay? Atomic number is not equal to, we can say that atomic number is always equal to the number of electrons. Now, if you consider sodium plus cation, right? You know that ions can be divided into two parts, cations and anions. If I consider sodium plus cation, here 11 and here 23. So 11 and 23. Okay. So in sodium plus cation, how many electrons are there? If I consider the number of electrons, there are 10. Number of protons, 11. Number of neutrons, so there are 12 neutrons. So you can see that, but when you consider sodium atom, see, in sodium atom, number of electrons are 11, number of protons are 11, number of neutrons are 12. So that means there is a difference, no? There is a difference. Electron count is decreasing. So therefore, we can't say that number of electrons, atomic number is equal to number of electrons all the time. Understood? We can't say that number of electrons all the time. But we can say that atomic number is equal to number of protons all the time. That's the best definition for the atomic number. Okay. So the definition for the atomic number is, what is it? Number of protons. What is the definition for the mass number? Summation of protons and neutrons. And remember, we are symbolizing an atom like this, right? Let me consider X, right? You already know about this notation. You have learned that one in all the time also. X. So here we have mass number, and here we have atomic number. Understood? So for the mass number, we are giving a symbol like capital A. For the atomic number, we are giving a symbol like Z. Understood? For the mass number, we are giving a symbol like capital A. For the atomic number, we are giving a symbol like Z. So you have to know about that one also. Right, okay. Then the atomic number represents number of neutrons, number of electrons and neutrons, number of protons, number of nucleons. Students, what does mean by these nucleons? Right, we have to learn something there also. Nucleons means, what does mean by nucleons? Anyone? Nucleons. Nucleon number. Do you have any idea about that? What does mean by nucleons? Anyone? Remember, nucleons means actually summation of protons and neutrons. Yes, Rahana, that's correct. That's correct. Okay. Nucleons means number of neutrons plus protons. Okay. So nucleon number. So nucleon number means actually that is mass number. So remember that, okay? Nucleons means number of protons and neutrons. So what is the nucleon number for the sodium? 23. Right? Mass number is actually known as nucleon number. Understood? So therefore the nucleons is number of protons and neutrons. So third one, the atomic number represents number of protons. 3, answer is C. Third one, answer is C. Right, okay. Do you have any doubts there? Raise your hand, those who understood up to now, everything that we discussed. All okay? If you have any doubts, you can ask me, right? All clear, right. Now, if you have any doubts, put your doubts in the chat box, okay? Right, next one, number 4. So number 4 is about isotopes, right? Can you remember isotopes? What does mean by isotopes? Students, isotopes means, do you have any idea about isotopes? What does mean by an isotope? What does mean by an isotope? Isotope is an different atomic number Yes, Ashfa, you are correct. Remember, isotope means same atomic number but different mass numbers, right? So when you consider atoms of elements, right? When you consider atoms of elements, so they can have different mass numbers but same atomic number. Because of what? Right? So that is the definition for the isotopes, right? Different mass number, the atoms of elements having different mass number but same atomic number. Same atomic number. They are known as isotopes. Different mass number and same atomic number. Okay. So how that the mass number is changing? How that the mass number is changing? Right. Now I'll take an example. If I consider a gas sample of hydrogen, just imagine hydrogen gas. Hydrogen gas is containing 3 different types of isotopes. What are they? Anyone here? What are the 3 different types of isotopes? 3 different types of isotopes. Different isotope types. Yeah, protium, deuterium, tritium. Okay, protium, deuterium, tritium. So when you consider hydrogen, hydrogen is containing 3 different isotopes. Hydrogen 1,1, hydrogen 1,2, and hydrogen 1,3. So this is actually known as protium. Protium means P. Then deuterium. Deuterium, that is D. And the next one is tritium. Tritium means capital T in this protium, deuterium, tritium. So what is the difference between these 3? Remember, electrons, protons, and neutrons. In protium, we have 1 electron, 1 proton, and 0 neutrons. Deuterium, 1 electron, 1 proton, 1 neutron. 1 electron, 1 proton, 2 neutrons. In this way. Understood? Right? So these are the electron count, proton count, and the neutron count of the isotopes. Okay. Right. So you can see that now you can have the answer why they have different mass numbers, because of the different number of neutrons. 0, 1, 2. Okay. 0, 1, 2. So you can see that 0, 1, 2, number of neutrons 0, number of neutrons 1 here, and number of neutrons 2 here. Right. So students, if I ask you a question like this, right? What is the only element in the periodic table which doesn't contain neutron? Right? In the periodic table, what is the only element which doesn't contain neutrons? It is hydrogen. All the other elements, right? After hydrogen onwards, helium, lithium, beryllium, boron, all the elements are having at least 1 neutron. Right? So hydrogen is the only element which doesn't contain a neutron, right? So that is actually a very important point that you have to note down, right? So let me write down here, not, since it is a very important point, let me note down that one here. Hydrogen is the only element, which doesn't contain neutron. Okay. So that's a very important point that you have to remember. Okay. Hydrogen is the only element which doesn't contain neutron. Okay. Right. So you can see that these are the isotopes. And another thing that you have to know, so this is actually related to our A levels. You didn't learn this one in O levels. This is known as relative abundance. What is it? Relative abundance. So what is meant by relative abundance? Abundance means capacity, right? Availability. Understood? So now when you consider protium, deuterium and tritium, relative abundance is high in protium. For an example, we can say that protium, right? These are not the exact value, but I'm telling you that as an example, right? So protium, its relative abundance is normally a relative abundance is expressed as a percentage value. We can say that protium's relative abundance is 99%. Then deuterium, its relative abundance is about 0.9. Okay. Tritium, its relative abundance is 1%, 0.1%, right? Deuterium, its relative abundance is 0.9%. Tritium, 0.1%. Protium is 99%. Understood? So relative abundance means availability. Now, if I consider, right, just imagine I have a sample of hydrogen gas. I have a sample of hydrogen gas. That hydrogen gas sample is containing, right, there are 100 hydrogen atoms. There are 100 hydrogen atoms. Then 99 will be protium. So that is the relative abundance. 0.9% is deuterium. 0.1% is tritium. Can you understand that? Availability. That's what meant by the relative abundance. In A levels, we are learning that isotopes are two types: stable isotopes, unstable isotopes. For the unstable isotopes, we are giving another name like radioisotopes. Radio means radioactive. Radioactivity means they can emit radiations. We are learning three types of energy radiations: alpha, beta, gamma. Have you heard them? Alpha, beta, gamma. So they can emit radiations, radioisotopes, unstable isotopes. Now, deuterium and tritium, they are unstable. Understood? So because you can see that according to the relative abundance, students, according to the relative abundance, you can say that protium is 99%. That means if I consider a sample of hydrogen, 99% will be protium. So therefore that is stable. Even in our atmosphere, 99% is protium. Understood? Then deuterium and tritium will be only 1%. Right? These are not the exact values. Again, I'm telling you that these values can be changed as a for an instance. Okay. Can you understand what does mean by the relative abundance? Raise your hand those who understood what does mean by relative abundance. If you have any doubts, put your doubts in the chat box. That's a very simple thing, right? Availability. Yeah, good. So we are doing some calculations regarding this relative abundance in our unit number 1. Okay. We are doing some calculations. Right. Then here, isotopes of the same element have different atomic numbers, same mass numbers, different number of neutrons, different number of protons. Students, you can see that isotopes are existing because of the number of neutrons, different number of neutrons. Here you can see 0, 1, 2. Different number of neutrons are there for protium, deuterium, and tritium. So therefore, we can say that question number 4, answer is C. Question number 4, answer is C. MCQ number 4, Answer is C. Right. Now let's move to the question number 5. Actually, you know the answer because I already told you what is the answer for that one. Can you tell me the answer for that one, students? The relative mass of a neutron is approximately 0.0005, 102. Yes, Ashfa, you are correct. What about the others? Yes, Rana, your answer is correct. Others? Yeah, Nilukshika, your answer is correct. Right? Okay. So now look at this. Relative mass of neutron is approximately 1. Because students, I taught you that what is the symbol of neutron? The symbol of neutron is N01. So this is actually relative charge. And 1 means actually relative mass. Relative charge and relative mass. So therefore, relative mass of neutron is 1. Okay. So question number 5, answer is B. Question number 5, answer is B. Okay. Right. The element with atomic number 12 is, right. What is the element with atomic number 12? What is the answer? No, it's not sodium. Can't you remember the first 20 elements that you learn in your level time? No, Nilukshika. Yes, it's magnesium, right? Magnesium. Okay. So let's revise what you learn in your O levels. Right. So when you consider the elements, look at this. We know that hydrogen, so here we have helium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. This is what you learn. Okay. So hydrogen is the first one, helium is the second. In this way. So therefore, magnesium magnesium is the 12th in the periodic table. Okay, right. So now you have already learned about these things in your order. First 20 elements are hydrogen to calcium in this way. Now my question is, right, let's go further. Let's go to A levels. In the periodic table, how many elements are there? In the periodic table, how many elements are there, as you think? In the periodic table? 108. Okay. Let's see your answers, everyone. One of you are saying it is 108, 118, 118. Okay. Any different answer? 118. Yes. Remember, in the periodic table, there are 118 elements. Okay. Under unit number 1 atomic structure, we are drawing the periodic table. I'm drawing this on this whiteboard, and when you get the tutorial, you are drawing that one on the tutorial. Periodic table is containing 118 elements. Understood? The periodic table is containing 118 elements. right? At least you have to remember 56 elements in the periodic table. Hydrogen to barium. Okay. I'll tell you that one why you have to remember at least 56. Now let's move to the next 10 elements. Let's study the next 10 elements because in our syllabus, unit number 6 is chemistry of SPD block elements. In that lesson, we are discussing about another 10 elements addition to these 20 elements. Okay. Those elements are belong to D block. Right? Do you know that the periodic table can be classified blockwise? That means the structure of the modern periodic table is, students, it's look like this. Do you know that? The structure of the modern periodic table is look like this. Right? In this way. So this is actually known as S block, blockwise classification. This is known as D block, right? And the next one is P block in the right side corner. At the bottom, we have F block, right? We are studying about S block, P block, D block, and we're not discussing about the F block in A levels, right? When you go to universities, when you do chemistry as a subject further, when you're learning further, then you will learn. In the D block, we are going to discuss about first 10 elements, right? 1, 2, 3. First 10 elements. What are they? Right? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You have to remember them. Study now. You can do it. Okay. Now, can you understand the first thing is the periodic table can be classified in this way: S block, P block, D block, F block. So likewise, there is a blockwise classification. Okay. So in O levels, you learn first 20 elements in the periodic table. You know what are the first 20 elements, right? Then 21st element, what is it? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, right? 21, 22, 23, 26, 27, 28, 29, 30, right? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, in this way, right? Shall we study this one, right? Once, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, right? 26th element is iron. 23rd element, vanadium. 29th element, copper. 21st, scandium. 30th element, zinc. So when you are given the atomic number, you should be able to tell the element. All right. Okay. At least now from today onwards, addition to those 20 elements that you learn in your O levels, right? First of all, let's study these 10, 21 to 30, right? start to study, right? Scanadium to zinc. Right, okay. Now, can you remember the first 30 elements? Okay. Right. Now you know the first 20, first 30 elements in the periodic table. Okay. Right. Okay. Now question number 6. The element with atomic number 12 is, it is Magnesium. So therefore answer is B. Okay. Next one. Number 7. The maximum number of electrons in the second shell is, right? Okay. So how do you answer for this one? Yes. Very good. Yes. Rahana and Nilokshika, your answers are correct. The maximum number of electrons in the second shell, that means second energy level, is 8, right? Right, now let's go for the energy level concept little bit, right? Look at this one. Now students, we know that around the atomic nucleus, there are some energy levels. That means electrons are revolving around this nucleus in certain energy path. Energy paths like this, right? In this way. In O-level time, you name them as KLMN, isn't it? You name energy levels as KLMN, right? But remember, in A levels, we are not going to denote these energy levels in this way, right? So how we are going to denote the energy levels, right? We are going to denote them as N equal 1, N equal 2, N equal 3, and N equal 4. First principal energy level, second principal energy level, third one, and the fourth one, like this. So we are going to name the energy levels in this way. N equal 1, N equal 2, N equal 3, N equal 4. First principal energy level. First principal energy level, second principal energy level, third one, and the fourth one. Understood? Now, we have learned that in the first principal energy level, how many maximum electrons are there? 2. In the second principal energy level, how many maximum electrons are there? 8. That is the answer. How many electrons are there in the third principal energy level? Do you know that? Now, you wrote the electronic configuration for calcium-like elements 2882, but it's not the correct electronic configuration. Yes, Rohana, correct. 18. Very good. 18. When we consider the fourth principal energy level, how many electrons are there? Yes, very good. 32. When you consider n equal 5, how many electrons are there? Anyone? In the fifth principal energy level, how many electrons are there? No. N equal 5, that is 50. Right? Okay, now let's go for a small math lesson. Now, this is the energy level. This is the energy level. And this is number of electrons. Number of electrons in that particular energy level. Can you get this one using a general formula? Like in grade 8, you learn that number patterns, right? Sorry. You learn common formulas 2n plus 1, 3n minus 2, 5n plus 3. Likewise, a common formula, a general formula. So likewise, in order to obtain the number of electrons, what is the general formula that we can consider? Right? What is the general formula that we can consider for that? You can try some maths. Number patterns. Remind that you learn number patterns in your O levels. In order to obtain the number of electrons, when you know the energy level number, what is the general formula? Okay. I'll give you 2 minutes. Try and tell me. Yes, you can try. Anyone? Yes, that's correct. That is correct. 2n squared, right? We know that is 2n squared. Okay. So we know that when you substitute n equal 1, right? When n equal 1, then 2 into 1 square, that is 2. N equal to 2 into 2 squared, that is 8. N equal 3. 2 into 3 squared, 18. N equal 4. 2 into 4 squared, 32. N equal 5. 2 into 5 squared, that is 50. In this way. Right? So therefore, remember the general term to get the maximum number of electrons that can occupy in a principal energy level is given by 2n squared. 2n squared. Okay? Remember that. Right. Therefore, we can get the answer here. The maximum number of electrons in the second shell is, what is it? 8. Right? Question number 7, answer is B. Question number 7, answer is B. Question number 8. The charge on an electron is, we learn it, no? Students, I told you that. What is the symbol of electron? E minus 1, 0. So here this 0 is representing relative mass compared to the mass of proton and neutron, mass of electron. Right. Okay. Are we done? If you have any doubts, any questions, you can raise your doubts in the chat box. Question number 9. Which scientist proposed the nuclear model of the atom? Right. In our first lesson, we are learning about the atomic models. What are the atomic models that we are discussing? Right. Atomic models. Okay, first of all, tell me the answer for this question. What is the answer for this question? Yes, Rahana, correct. Which scientist proposed the nuclear model? Who is he? Rutherford. Rutherford is the scientist who proposed the nuclear model. So therefore, atomic models. Under atomic models, right, there are 5 atomic models that you should know. The first one, the first atomic model is known as, anyone? Yes, you can try. Try it. What is the first atomic model? What is the first atomic model discovered? Planetary. No. Okay. Remember, students, don't worry, I'm going to teach you these things. We consider that one as, sorry, Dalton's golf ball model. Okay, Dalton's golf ball model. Then the second one is Thomson's plum pudding model. Thomson's plum pudding model. And the next one is Ernest Rutherford's nuclear model. Okay, Rutherford's nuclear model. And the fourth one is Niels Bohr energy level model. So the final one, in the modern science, in the modern world, we are using electron cloud model, or else this is known as quantum model. Quantum model. Understood? These are the atomic models that we are discussing. In our theory class, we are discussing about these 4 atomic models in detail. I'm going to give you a small introduction about this electron cloud model also. Okay, especially the Rutherford's nuclear model, we are learning that one in detail. Right? What is that experiment? Who conducted? What are the observations? What are the conclusions and everything? After that, Bohr's energy level model also taking very important place when we are discussing about the atomic models. The first 2 models are very simple. And remember, Dalton's golf ball model is very ancient. Dalton assumed that atoms look like a golf ball. Some says billiard ball. Right? If I asked Dalton to draw the atom, he could have drawn a circle like this. That's all. That's you all know about that. That's all. Golf ball. We know that golf ball is very hard, indivisible, uncuttable. Right? So that's what he considered as an atom. Then Thomson said that atom is there is a positively charged sphere where electrons are embedded on it. Plum pudding, we know that pudding, right? That positively charged sphere is the pudding, and plums are the electrons, right? Positively charged sphere where the electrons are embedded on it. That is Thomson's plum pudding model. And the next one is Rutherford's nuclear model. Rutherford is the first person who discovered the atomic nucleus. For this, Rutherford did an experiment. It is known as gold foil experiment. Students, before we learn this one in detail, if you want, if you are interested, if you are eager, you can find out the details. What is this gold foil experiment through YouTube? You go to the YouTube and type gold foil experiment, then you can see the videos of it. That is very interesting. Rutherford discovered that the most of the space in the atom is empty. I told you, right? Football ground example. If I consider an atom, only the middle part, this is the place where the nucleus is located, neutrons and protons. And the other space is empty. In that empty space only electrons are located. But we know that electrons' mass is negligible. The total atom mass is depending on this small area. Understood? Okay. So therefore, Rutherford is the first person, right, who discovered the atomic nucleus. That's why it is known as Rutherford's nuclear model. Some people say that Rutherford's planetary model, it's like that kind of planets are orbiting the sun, electrons are orbiting the nucleus. That's why it is known as Rutherford's planetary model. After that, the development of the Rutherford's nuclear model given by Niels Bohr, a scientist known as Niels Bohr. Niels Bohr said that electrons are revolving around the nucleus in certain path. So those paths are known as orbits. Orbit. Or else it is known as, the most generalized term is energy level. As I told you, n equal 1, n equal 2, n equal 3, those are the energy levels. Understood? Orbit or energy level. Got it? So he gave the idea for the energy levels. That means Rutherford couldn't explain how the electrons are actually behaving, the behavior of the electrons around the nucleus. But Niels Bohr, he explained how the electrons are behaving located around the nucleus. Electrons are located in certain energy paths known as orbits or else energy levels. Now, in the modern world, in the modern science, we are discussing about electron cloud model or quantum model. That means, students, there is no energy level concept or anything like that. Right? In the quantum model, in the electron cloud model, we tell that nucleus is there. Around the nucleus, we can see electrons are gathered around that nucleus as an electron cloud, like this. There is no energy levels. Electrons are gathered like this as a cloud. This is known as electron cloud model. Understood? So this is what we are learning in the modern science. Quantum model for the atom. Understood? Right? We are discussing about the first four in detail under theories. Especially the gold foil experiment is taking a very important place in these atomic models. Okay? Right. Which scientist proposed the nuclear model of the atom? Answer is Rutherford. Question number 9, answer is B. Question number 9, answer is B. Right. Number 10. Which statement about neutrons is correct? They have no charge. Yes. That is the first answer. First answer, no? I told you that neutron means what? Again, I'm drawing that N01. This is the symbol. Right? This is the relative charge. This is the relative charge of the neutron. And this is the relative mass of the neutron. Okay. So therefore, neutron, they have no charge. Simply. They are positively charged. No. They orbit the nucleus. No. Electrons are orbiting the nucleus. They have mass number 0. No, no, no. Relative charge is 0, not the relative mass. Question number 10. Answer is A. Right. Very simple MCQs that you can revise what you learn in your O levels and you can bridge them to our A levels. I gave you some tips that you have to learn about, learn in A levels, right? Especially these atomic models, the isotope things, right? The summary of the subatomic particles. Again, we are revising that one under unit number 1. Okay, that's why I told you that. So here we are giving us some kind of what? A boost, right? A foundation, right? A proper foundation for the lesson that we are going to discuss. So today in these sessions, try to get an idea. That's all. Okay, students. During March month, you can get an idea, right? This is not to study, memorize, or anything. You will have the tutorial. You attend for the session, right? In case if you can't attend, you can have the recording. So you watch them and you try to get an idea. That's all, right? Think in this way, and you can question. You can question me. If you have any doubts, you can ask me. From April month onwards only, we are starting our proper lesson. Understood? Right? Now you just attend for the sessions and get an idea. Don't be too much serious. Okay? Is that clear to you all? All okay? Right, okay. So raise your hand those who understood the 10 MCQs that we discuss here. Is everything clear? Do you have any doubts there? I hope that you understood everything that we discuss here. If you have any doubts, please put your doubts in the chat box. Right, good. Okay. And remember, students, now some of the students ask me that is this the permanent time? Yeah, this is the permanent time every Tuesday, 8 p.m. to 11 p.m. That means when we are starting the theories, our class will be 8 to 11. But in the foundation month, in this March month, I'm conducting up to 10 or 10:30 wage. But from April month, up to 11. But anyway, this is the fixed time. Tuesday, 8 p.m. That is the fixed time. Until your examination, Tuesday, 8 p.m. is our online class time. Understood, right? Okay. And tomorrow onwards, I'm going to post your tutorials. So therefore, don't worry. You will get the tutorials before next week. Okay. And I'm going to send you our recordings also. And if you want to know anything about the classes, any recordings, any tutorials, please contact admin. So you can get everything through admin. Okay. And I'm sending the messages to the WhatsApp group. Please watch the WhatsApp group also. In the WhatsApp group, sometimes I might add some materials. I'll send you our resource book PDF. So therefore, please keep in touch with our WhatsApp group also. Okay. No, 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 no. You don't have to remember these things now, right? I told you, no. When first unit is starting, when we are starting unit number one, you start the work. Don't worry, others are starting, other tuition classes, they have started unit number one, they have finished unit number one, they have done atomic models, they have covered the subatomic particles. You don't worry about anything. Okay? You start smoothly, will you? Right? Everyone is starting the race at the same time, but not everyone is finishing that one properly, no. Right? It's not about only the starting. You have to continue it. You have to finish it properly. So you smoothly start, will you? Listen to these things, will you? You just get an idea. From April month onwards, let's start our work. So therefore, you don't have to memorize these things, anything here, right? In this foundation program, during this March month, you just get an idea about the subject. That's all. Because some of the students are there, actually, they do not about our subject. What is this subject? What we are learning here? Right. Some of you may have on the fence whether I'm choosing ICT or chemistry. So for those students, they can get an idea about what we are learning about this subject in A level. Okay. So therefore, nothing you have to memorize here. Okay. Right. If you want, you can note down anything that I'm going to write down on the whiteboard. Other than that, don't try to memorize now. Right. Just listen, get an idea, think, ask the questions. Right. Let's make this one is a very interesting session. Right. Okay. Now MCQs are over. Now, students, I'm going to move to our structured essay questions. These structured essay questions are very easy. Okay. So what is cathode rays? Yes, we are learning cathode rays in the first unit. That is our starting theory part in the unit number one. Cathode ray experiment. Remember, students, cathode rays means actually none other than electrons. So I told you that we have a story to discuss about the electron now. So that means in order to discover the electron, so they conducted an experiment. That discovery of electron was actually accident. Right? J.J. Thomson, Julius Plucker, Wilhelm Hittorf, right? William Crookes. They conducted an experiment to pass the current electricity through gas medium. But finally, they discovered that there are some radiations going from cathode to anode side in the cathode ray tube. So they discovered that one as cathode rays. Finally, By conducting few experiments by J.J. Thomson, he concluded that cathode rays are electrons, negatively charged particles. Okay, so cathode rays means actually none other than electrons, a beam of electrons. Understood? Rana? Right. Okay. Now let's move to the structure essay questions. Question number 1. Right? Find the number of protons, neutrons, electrons in an atom. Chlorine. Right? Students, you know that chlorine is 17. So this one should be chlorine 37. Mass number is 37. They have given the mass number. Okay. So here in this atom, they're asking about number of protons, neutrons, and electrons. Very easy. Students, answer me. How many protons are there? Right? How many electrons are there here? In chlorine 17. So there are 17 electrons. How many protons? 17. How many neutrons are there? We know that this is the mass number, no? Right? This is the mass number. That means number of neutrons plus proton summation is 37. We know that protons are 17. So therefore, we can take that neutrons are 20. So the number of neutrons are 20. Okay, that's very easy. Question number 2. What is an isotope? Right? Isotope. The element with atoms having different mass numbers, and same atomic numbers. Same atomic numbers are known as isotopes. Okay, right. That's very easy. Question number 3. Write the electronic configuration of sodium, sulfur, and calcium. Right? Students, now in your O-level time, you learn the electronic configuration of sodium is 281. That is the electronic configuration that you learn in O-level time. But it's not correct here. I told you that. We have to discuss about sub-energy levels. Do you know that? Energy levels can be further split into sub-energy levels. First principal energy level is containing a sub-energy level. Second principal energy level is containing 2 sub-energy levels, S and P. Third principal energy level is containing 3 sub-energy levels, S, P, D. Fourth principal energy level is containing 4 sub-energy levels, S, P, D, F, like this. Okay? In this way. Energy levels can be further split into sub-energy levels. Right? So, sodium's configuration can be written as 1s2, 2s2, 2p6, 3s1. This is the electronic configuration for sodium. First principal energy level is containing S sub-energy level, right? Remember students, S sub-energy level can contain maximum 2 electrons, right? P sub-energy level can contain maximum 6 electrons. D sub-energy level can contain maximum 10 electrons. F sub-energy level can contain maximum 14 electrons. The next one is G sub-energy level can contain maximum 18 electrons. I didn't mention this one here. Understood? Right? So therefore, Electronic configuration for sodium is 1s2, 2s2, 2p6, 3s1. In the first principal energy level, there is a sub-energy level containing 2 electrons. In the second principal energy level, there are 2 sub-energy levels known as S and P. S is containing 2 electrons, P is containing 6 electrons. Right? Third principal energy level, S is containing, in this way. Right? What is the electronic configuration for sulfur then? You just try. You just try that. Now here, sodium's configuration. Look at this. In the first principal energy level, there can be 2 electrons. No. In the second principal energy level, you can see that 1s means first principal energy level is sub energy level. 2s means second principal energy level is sub energy level. 2p means second principal energy level, p sub energy level. I told you that second principal energy level is containing 2 sub energy levels, S and P. Got it? So therefore that p sub energy level can fill 6 electrons. And this is 3s1. Right? Same thing, you can see that me. 2, 8, 1. This 6 and 2 is 8, 1. The only difference is that 8 is separated into 2 and 6, separated to sub-energy levels. What I want to teach you here is energy levels can be further split into sub-energy levels. In A levels, we are discussing about sub-energy level concept. Peter Zeeman and Johannes Stark, they found that the existence of the sub-energy level, Zeeman effect and the Stark effect. Understood? You will learn them. Take the idea, energy levels can be again split into sub-energy levels. In the first principal energy level, there is only one sub-energy level known as S. In the second principal energy level, there are 2 sub-energy levels known as S and P. In the third principal energy level, there are 3 sub-energy levels known as SPD. In the fourth principal energy level, there are 4 sub-energy levels SPDF. Can you understand now? Right? That means the number of sub-energy levels is equal to the energy level number, no? Right? 3 means 3 sub-energy levels. 4 means 4 sub-energy levels. Likewise. These are the maximum number of electrons that can occupy in each sub-energy level. Understood? Therefore, sulfur's electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4 in this way. See, but you are writing that one in O-level time 2, 8, 8, 2, 8, 6. This is what you learn. No? But still that 2, 8, 6 is there. No? 2, 8, 6. But here that 6 is separated into 2 and 4. Sub-energy levels. C, calcium. Calcium configuration can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Right? You're learning this one as 28882. This is what you learn in O-level time. But still that one is here. Eh? 1s2, 2s2, 2p6, 8. 3s2, 3p6, 8 here. And 4s2. That is containing 2 electrons. Can you see that? That is the difference between O levels and A levels. I'm not teaching you how to write down the electronic configuration here. Before you learn the electronic configuration, you have to learn so many things. Aufbau principle, Pauli's exclusion principle, Hund's rule, energy level order. You didn't know about anything, right? So, but here I'm going to teach you that something like energy levels are there. When we write the electron configuration, we are using energy levels also. right? In this way. You didn't know that one, right? Now you know it. This is what happening A levels, right? Can you understand the concept? Yeah, if you have any doubts, you can ask me. Right, okay? Done? Do you have any doubts there? Yeah, I'll send you the recording. Yeah, sure. It should be 4 if no. So where is 4 if? No, 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 no. 1s, 2s, like this. See, in this way. We have to complete the first energy level and its sub energy levels. We have to complete the second energy level and its sub energy levels. And we have to complete the third principal energy level and its sub energy level. But in calcium, there is an exception. Before we go for the D sub energy level of third principal energy level, it's going for the fourth principal energy level. Okay, don't worry about that one, right? So we have to discuss so many things before write the electronic configuration. But here I have gave you an idea, okay? So don't think about it much, right? Okay. Number 4. Question number 4. An element capital X has atomic number 11. Students, what is the element with the atomic number 11? You know it. Element with the atomic number 11. What is it? Sodium, right? Sodium. Remember, sodium's atomic number is 11, mass number is 23. State the number of energy levels and valence electrons, right? Students, remember, we know that when we consider sodium atom, right, these electrons are filled to 3 principal energy levels. Okay. In the first principal energy level, there can be 2 electrons. So in the second principal energy level, there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. In the valence shell, right? Valence shell means the last principal energy level. So it is also containing 1 electron. Okay, so therefore, state the number of energy levels and valence electrons. So how many energy levels are there? Number of energy levels. So here number of energy levels are 3. And how many electrons are there? Valence electrons. So there is only 1 electron. Valence electrons means, remember, the electrons located in the last principal energy level, valence shell, right? This is the valence shell, right? This is n equal 1. This is n equal 2, second principal energy level. This is n equal 3, third principal energy level. Third principal energy level is the valence shell. Okay. So therefore, number of energy levels will be 3 and the valence electrons will be 1. Now let's go to the question number 5. Question number 5. Define atomic number and the mass number. It's very easy. Atomic number is denoted by Z. Right? So what is atomic number? Number of protons. Then define mass number. What does mean by the mass number? Capital A. Mass number means summation of number of protons plus number of neutrons. In this way. So that's very easy. Right. Students, first topic is over. So our first topic is atomic structure. So any doubts, anything that you want to ask? All clear? Raise your hand those who understood the things that we discussed today. Okay. Any doubts? Right. Okay. Now, so students, remember, I want to remind you a few other things. If you have any doubts, put it doubts in the chat box. Okay, I will answer for you. If you are doing biology, by now you know that. I think I forgot to tell you this one in the introduction session. Yes. Did I tell you about anything about the resource book? A-level resource book? Did I tell anything about this? No. Right. Okay. Yes. I think I forgot that. Students, for those who are doing A-level chemistry, you have a resource book for biology, for chemistry, and for physics. There are 3 resource books. For the combined maths, as I know, there is no resource book. So resource book is kind of a textbook, right? It's not exactly a textbook. So it's kind of a textbook, right? For in A-level chemistry, right, for our chemistry subject, there is a resource book like this. I'll show you the first resource book that you have to buy. Can you see that, everyone? Can you see the book? GC Advanced Level Chemistry, Grade 12, Resource Book, General Chemistry and Inorganic Chemistry. This is the first book that you have to buy. And you can see that. So, who issued this book? Department of Science, Faculty of Science and Technology, National Institute of Education, Maharagama. www.nie.ac.lk. Right? You go to the Google and type NIE, right? In their website, the PDF version of this book is available. You have to buy this resource book ASAP. What is ASAP? As soon as possible. Okay? Because when you attend for the classes, you should have this resource book with you, and my tute should be there with you, and the question books. I'm giving you in April month, you will have another 2 tutorials, Atomic Structure Part 1 and Past Paper Question Book. So both are there, right? So therefore, first thing is actually you have to buy this book because this is kind of our resource book. Understood? In this resource book, unit number 1, unit number 2, unit number 3, and unit number 6, right? Unit number 1, general chemistry. Okay, you have to buy general chemistry resource book. Those who are live in Colombo, you can go to Maharagam NIE bookshop and you can buy the first book. Okay, unit number 1, 2, 3, and 6. Then there is another book for unit number 4 and 5. Then there is another book unit number 7, 8, 9, 10. So 11, 12, 13 in another book. Unit number 14 is in a separate book. So that means how many books that you have to buy? So there are 5 books that you have to buy. Okay. Likewise, there are 5 books. So you can buy one by one. Okay. You don't have to buy everything at once. So buy one by one. First of all, you have to buy this. Understood? Because this is kind of a textbook. Everything is there. So I forgot to tell you this on another introduction session. That's why I told you this one here. Okay, when I start the lesson, when I'm starting the lesson, you should have this one. And those who are living outside Colombo, you can purchase this one through some sites. They actually, you know that Copier Store. Search that one in Google or in FB. They are maintaining a FB page. School Paper Bank, copierstore.lk. So likewise, there are some dealers that they can send you the hard copy of the book. Understood? So otherwise, you have to go to the Maharagam, and the next option is you can download the PDF. And but remember, the PDF available in the site is not upgraded; it is old version. Okay, so you have to buy the new version of the book. Anyhow, you should have this resource book with you when I'm starting the lesson. Unit number 1. Okay. Yes. Yeah. When I'm starting it, you have to buy it. That means now when you buy this resource book, you can keep this one until unit number 3. When I'm starting unit number 4, I'll tell you, then you have to buy unit number 4 and 5. Okay. So yeah, if you can purchase everything at once, but if you can't purchase in that way, you can go one by one. I'll let you know when you have to buy the second one. Don't worry about it. Understood? I want to tell you this one, but I forgot to tell this. Right. Okay. So how was the first session? Is everything clear? Everything is perfect? I discussed only one topic today. Was it interesting? Do you learn good? Do you learn things that you have already learned in O level? Did you polish everything that you learned in O levels? Don't you have any doubts? You can ask me any doubts if you want. Yeah, this is not fully basic, okay? So we can't do completely basic stuffs, right? That means I told you, this is kind of what? Bridging. O level to A level, bridging. A smooth transition. I want to first of all take you to A level smoothly without suddenly jump to there. Understood? So you might think that some of you might think that these things are, we have already learned these things in the O level. So therefore we know everything. We know everything. But when you go for the next few topics, they're not easy, okay? Periodic table and then calculations are there. Chemical bonding is there. Stoichiometry and mole concept is there. Organic chemistry, basic organic chemistry, and oxidation reduction, redox. You haven't learned those things ever, I guess. So therefore, it's not easy. Okay. So this is the tude that you will get in the next week class. Okay. Pre-A level foundation program. And you will have a file cover also. So this is the file cover that you get. So tomorrow I'm going to post the tude and the file cover to you all. Those who sent addresses, you will get the tude before next week class. Okay. So those who didn't send your addresses to our admin Amasha, so you can send your address to her, and I'll send you a tutorial before the next class. Okay. In the next class, we are going to discuss the remaining questions. But students, you have to do something like this. As a homework, can you do this one? As a homework, can you do topic number 2? It's very easy. It's not hard. Periodic table questions, and there are 10 multiple choice questions, MCQ questions. There are 10. And structure essay questions are there. I think there are 5 structure essay questions. Yeah, in that topic also. Can you do them before the next week class? Raise your hand, those who can do that. Do means you can try that one. I'm going to discuss these things, don't worry. In the class, I'm going to discuss these things. So 10 MCQs and 5 structure essay questions. But before that, I want all of you to try these things. And those who completed this topic 2, you can go to the topic number 3 also. And come up with the doubts. That means, so why these things are happening, right? So I told you, last week, you should have a curiosity, right? You should be very curious to learn. Now, some of you ask me that why these sub-energy levels, what is that SPD? Likewise, no, SPD means sub-energy levels. I explained you that. So likewise, that curiosity is making you to learn this subject properly. Understood? So before you come to the class, next class, try the topic number 2. If you can try topic number 3 also, come up with the doubts. And we can have a very interesting interact session. Understood? Right? So therefore, try that one before the next week class, okay? Any doubts? Ashfa. Oh, okay. No, don't worry. Ashwa, it's like this. Don't worry about those things, okay? If you're feeling like these things are complicated, that's completely all right. Right? That's what I want from you all. Because from that, you have to understand that this is what A level is. Right? So you can't again expect everything that you learn in O levels. Right? I explain you here O level things and some A level stuffs also. And you should be able to compare that one. You should be able to bridge that one. This is the difference between O level and A level. That is our target. That is our intention. That is our target to conduct this program. Okay. So nothing to worry. Can you understand what I'm explaining, what I'm saying? That's what I wanted to know about. Is it okay? My teaching and everything okay for you all? That means, can you understand? Yeah, gradual learning will help. Yeah, exactly. You keep on going, will you? You keep on going. Don't worry. Okay, right. Yes. Let's move little by little, okay? Don't take too serious. Don't take too hard. So let's go smoothly. Don't worry. As I told you, you don't have to memorize. You don't have to study. You just come and listen. And I'm going to teach you a few things. Try to understand. Ask questions. That's all. Okay. Right. Then students, as a homework, try this one. Okay. And keep that in your mind. As I told you, please buy the resource book. That's very important. Okay. So in the next class, we will be discussing topic number 2 onwards and try those questions. We'll be discussing those questions in the next class. All right. Okay. Then, as I told you, if you have any doubts regarding the class recording, PDF, tudes, please contact admin Amasha. She's there in the group, right? So she will send you the links and everything personally. So you can contact her. Okay. From April month onward, as I told you, we are going to start our unit number lesson properly, our syllabus, and the class is conducted from 8 to 11 from April month onwards. Tuesday, this time is our permanent time. It's not going to change. All right. Until the examination, this is our permanent time. Right. Okay. Then students, let's meet on the next week class. Until then, bye bye, have fun. Good night for all of you. God bless you.